And students, this is tutorial. I today discuss about statistics. I have already introduced statistics, and I have already described what is PDA or probability density function, what is PM probability mass function. These are already discussed. Now today I will discuss about distribution functions. Very important. There are many categories of distribution functions, and I have also said that there are two types of uh, mm, distributive function. One may be discrete type, one may be discrete type, another may be continuous type, and the second may be continuous type. Continuous type of distribution. So first we discuss about discrete distribution functions. Let's start. Discrete distribution functions. Important. Discrete means they must have finite values. Distributive and distribution function. I've already said what is distribution functions. These are probability functions actually. In my one video about probability mass functions and probability density functions, I already uh, said what is distribution functions. So watch those videos, find out, search with my name, search by my name, videos by Niranjan Saha, and you will get all the videos. Search videos by Niranjan Saha, then you will get all those videos, and you, as you like, can watch those videos. Videos by Niranjan Saha. Google search or YouTube search you can do, and you find out all these videos as you like, as you demand, you can watch. So first discrete distribution functions. So first one are is casual distribution. Very simple casual distribution. So I am assuming that you must watch my videos. That's why I have not discussed about distribution function. I have already discussed in my videos what is distribution function. That's why I am not discussing today. Just I am going through the all type of discrete distribution function. Casual distribution function. In short, it can be written casual distribution function. DF. So here all the value, the variable, the random variable can take is called its spectrum. So all the variables. So here may be a lot of variables, finite number, infinite number. If there is only single value, single variable value, the random variable can take in its spectrum, then its probability mass distributive function is called casual distributive function. Distributive function is denoted by f, and with taking random variables values, it is actually it will be written in this way: p x. Here x can be take just only one value, x equal to a. So probability of a single point must be 1. It is a sudden incident, so it is 1. So uh, just varying a is a parameter. You can take any value, one value just, but it is a varying parameter, but you can take just only one value, not more than one, only one value. And any value you can take just one value. And if you will generate distributive function, then you will get the distributive function equal to 1. This type of distribution is called casual distributive function. Now second type is the now important distribution is started, binomial distribution. I hope that you all know about binomial expression. By if you remember what is a binomial expansion, binomial distributive function. There binomial expansion actually written in this way: n c r summation also, where r can be 0 to n x n minus r and yr. It is a binomial expression of what? X minus yn. X minus yn. So I am just give you the memory what is a binomial expression. So now binomial distribution function is that here the spectrum random variables can take n plus 1 points. It can take up to 0 to 0, 1 to up to n value. So up to n value, so there are n plus 1 number of values in the random variable. Now we can write the distributive function in this way. This will be the distributive function will be binomial distribution function will be n c I each any value among them, and say any value among them, and we have I here to clear it, and this is the probability of having the ith number of sets probability of happening. So this is p I, this is p I it is its index, and not having the ith component is 1 minus p. So here it is to be noted that p is the chances of happening, and 1 minus p is chances not happening. This is n minus I. So you can now compare it with the binomial n minus I. Binomial expression, it is equivalent to, but there is a difference is that it is the ith number of binomial term, just ith number of binomial term, first, second, third, fourth, any number of terms distributive function is expressed by this. This is n minus I. So I hope it is clear now. And p is probability, so must be equal to 0 to 1. P must belong to 0 to 1. Anyone cannot be a certain one, must be less than 1. And of course, p probability is greater than 1, greater than 0. So, this is the condition of binomial distribution. Now, one more distributive function is a distribution function is a Poisson distribution. Poisson distribution function is also very important. As the binomial distribution important. Many problems are solved by binomial distribution and Poisson distribution. So these two are very important and very essentially you need to study this. Here spectra is all non-negative integers. All integers, positive integers. All positive integers are belongs to the spectrum of the set of random variables. So here it is infinite number of non-negative integers. Here also the random variables take these values any 1, 2, 3, 4, any positive integer 0, 1, 2, 3, 4, anything. And there are infinite number of this is a crucial point from the difference between the binomial and Poisson that there is infinite number of points and in binomial there are finite number of points. So this is the difference and the distributive function is for the ith component ith number of point the random variables distributive function will be exponential e to the power minus mu. Mu is the average or mean. Mu is the average or mean actually in the Poisson distribution. Mu again mu the means index of power is I by I factorial. This is I factorial. This is I. This is I factorial. So this is our Poisson distribution and mu is greater than must be greater than 0, never equal to 0. And I already said that this is the mean or average in Poisson distribution. I'm not going in long discussion. Just I'm giving a deep concept about Poisson distribution, binomial distribution. So when I will go in long discussion, then I'll prove that mu is equal to its average or mean. I'm now leaving this topic, but it is very important. And if you need to know, then you go through a book, then you can easily understand why I am saying it is a mean or average of the distribution. Now, one more. It is also important, but its use not huge as binomial or Poisson geometrical geometrical distribution function geometric geometric distribution function. So here the distribution function written is a distribution function is a probability function actually. So here the distribution function is written in this way that it will be equal to P. P is the probability of happening of the value x equal to here I am giving x. Small x is the value where random variable can take many values. So it is taking x or any other value. I am taking less small y. So x can take a value y. So probability of happening y is small p and q is that there are chances the not happening of y taking the value of x will not take the value y each q, and the chances of taking the value x equal to y is probability p. This is in the power ax, q to the power ax, when and there is a when it is given that when x belongs to positive integers, x belongs to positive integers, 0, 1, 2, 3, 4, these numbers, and p and q lies between 0 to 1. So here p can be 1. Here geometric means geometrical distribution function p can be 1 or less than 1, and q of course can be 0 or equal to or less than 1, and it is equal to 0 otherwise. Otherwise means if it not defined, if you don't find out in the defined region, then it will be 0 otherwise. For other values it is not defined, this will be 0. This is a geometric distribution. Just for if x takes the positive integer value, then it is defined and it will equal to the probability p and non-probability q to the power x. Otherwise for other values it will be 0. So these four type of discrete distributive functions I have already discussed. Now I will discuss continuous distribution. So continuous distributions, continuous distributive functions. Continuous distributive functions also several types. Some important ones I want to discuss. Like first, uniform distribution, rectangular distribution. It is popularly known as uniform distribution. So I'm writing uniform distribution. And it is also called rectangular distribution, uniform distribution function. You know that it's uh, probability. This is a probability function. So its form of equation, it is the new term I'm using, form of equation, or if you want to draw a sketch in a curve on the Cartesian plan, then the equation of the representation or the equation is the is a function which is called also probability mass function, and for continuous distribution it is called probability density function. So for the uniform distribution function, the density function is given by fx. Capital F is used for distribution function and small f is used for their uh, equations, or to represent the dependent variables equation. Means x can take any values, any random variable, x a random variable can take any value, and that it is independent, and the dependent function is called the probability density function. Here it is a distribution function or probability function. It is in Cartesian plan shows a region area, and the probability mass function shows a curve, or curve straight line, anything maybe. So here it is. So there is the difference that you are giving is capital F or small f. It is equal to 0. It is defined as 0 when x is defined through minus infinity to if x is taking value minus infinity to a. 1 by b minus a, 1 by b minus a. For part of the video, I am not showing the sketch or diagrams. Actually, these are also very important. You need to go through book, and I will try in another video to give separately all the distributions diagram. So in this video, short video, I could not provide this. For sorry for this inconvenience. I'll try another video separately try to understand how the distribution function behave in diagrams. So wait and watch my videos, continue, and very soon try to lodge a video on this topic. If x take the value in the open interval AB, then it will be the distribution function will be 1 by minus x, and it will be 0 again if x belongs to b to infinity. So if x is equal to a or x is equal to b, then what will be? So it does mean in the distributive functions the range shows that actually here we can use equations. In statistics these are not important. You will have to take your through your own assumption that if it is a open interval, actually you can take it as a closed interval, so it can take the range b to a, b the limiting value and a the limiting value also, and find the distribution function of uniform distribution function. So if you want the PDF for the density function, then you have to just integrate this functions with respect to the integral, with respect to the integral. You have to integrate with respect to the random variable, and as you want to um, and you have to take the differentiate form also. It's the differentiate form because the district function is a region. I have already said in diagram. So it's if you will differentiate it, then you will get the probability density function, and if you will integrate that, then you will get that the value you wish to know. So you will get the distributive function again actually. So then you will get the cumulative distributive function. So many things are to be discussed. So here I am just discussing the types of the distributive function. So I am leaving this method, and I have already said what is the uniform distribution. Second, normal distribution. This is very important, and is the most widely used normal distribution. So I am sorry again for not providing any graph or such kind of distribution. Just I am uh, touching the distributive function, not providing any of the topics longly. So now normal probability distribution function is that, and this will be here. I have done one mistake. Sorry for this. That actually this is smaller, means this is probability density function, not I am erasing and rewriting it. It's not the distribution. There is a difference. You will have to mark it. That I am writing here now probability density function, not the distributive function. So this is the defined different distributions are probability density function, not distributive function. If you do now wish to find out the distributive functions, probability distributive function, so you need to integrate it then you will get unity distributive function. So here uniform distributive function of this is a PDF probability density functions. This is probability density. Again, I am writing probability density function of normal distribution. This will be this is again small effect, and this is 1 by sigma into over 2 pi. Try to remember very important form, exponential minus half uh, minus half, and in the index this is with minus half uh, x minus m by sigma. I am giving the terms used here. X minus m by mu is the mean or average, sorry, mean. This is also sigma to the power whole square. So exponential this exponential of it. So here the question is that what the values x can take. X can take infinite number of values. X can take infinite number of values. There is no restrictions on any real value can x take. And now m and sigma, there are two other things. M and sigma, you can look, these are parameters. M and sigma are parameters. These can be changed as you like, and it is all in short written that this is denoted the probability density function M sigma. So the uh, value of M or sigma you will take, the form also will be changed by taking the values of x. So there are different values of M and sigma, and you will take different values of x, you will get different normal distributions. So I am remembering, I will giving an example. Probably normal distributions find out in this way, for some m and for some sigma, different m and different sigma, you will get this such kind of value, and you can get also in this type of value. So there is for another m, this is m1 sigma 1, this is m2, this is m2 sigma 2. Actually, these curve are probability density function, and if we want to provide a distributive function, then the whole region will be the whole region will be the distributive function. So many things we have to study. We have to take another topic on normal distribution. Then we will discuss. There I am giving light discussion on normal distribution. Very important. That's why. Now I am leaving this normal distribution. Famous one also I want to and provide. This is m is equal to 0 and sigma is equal to 1. Then the normal distribution is in this form. This is actually will be 1 by root 2 pi, and all the data will vanish automatically. Integration of minus infinity to x into the power minus x square by 2 dx. It is a very common or not general form of the normal distribution. Now we study another one. These are also important. This is Cauchy distribution. Cauchy distribution. So here we will get Cauchy distributive function, the probability distributive function, density of sorry probability density function. The probability density function is that Cauchy probability density function. Here will be fx equal to 1 by pi uh, lambda lambda square plus x minus lambda whole square x minus x minus mu sorry, mu whole square where x can take any value from minus infinity to infinity. So lambda and mu are parameters here. The two new members you are looking. Lambda and mu are parameters. And one more distribution, gamma distributive function. Gamma probability density function will be fx equal to this will be exponential e to the power minus x to the power l minus 1, and there is a gamma function gamma l. You know, I hope the behavior of gamma function. So when here x is positive once, it must be greater than 0 and less than any finite value, or it is infinite, and it is 0 others means for the negative ones it is 0. Yes sir, for the negative values of x this is 0. The gamma ratio for the density function is 0 for negative values of x, and for positive values of this function will be the probability density function. And last one, beta distribution function. Beta distribution function. Beta PDF. So there are two types, first kind and second kind. So first kind I am writing first. First kind. First kind will be the probability density function f is equal to x l minus 1 minus x minus 1, and beta functions. If you know the behavior of beta function, then you can very easily understand the behavior of probability density function. You find x belong to the uh, x belong to 0 to 1, otherwise it is 0. So this is a restriction, otherwise this is 0. Yes sir, for other values the probability density function is 0. And second kind, Second kind will be for detention function if x is equal to another form x l minus 1 beta l 1 plus x l plus 1 m. So this is the probability density function of second kind of beta function, beta distribution. So here x can vary not 0 to 1 but 0 to infinity. And for other values, actually for negative values of x, it is 0. So these are the continuous distribution functions I have discussed. So for discrete type of distribution function and six type of continuous distribution function I have already discussed. So I am not discussing more today. Separately, I will discuss later with diagrams also. So continue to watch this video. Watch this video. I am only at first said that how you can search my videos. So search my videos and watch continue videos. Subscribe this channel to get the notification. Subscribe to continue getting notification of my uploading videos. And share with your friends if you like, then like me and comment me. Thanks for watching.